My name is Zhonghua Chen. I'm a professor in agriculture and horticulture. So I started here 11 years ago as a research lecturer in greenhouse horticulture. So my main mission in this university is to build greenhouse horticulture. In other words, in Australia, protect cropping at Western Sydney University. Currently, I'm leading one project through the CRC. It's called Sustainable Fertigation. So we are looking into fertilizer use because fertilizer use is a big issue in agriculture and horticulture. There is an estimated 40% more waste of fertilizer. A lot of those fertilizer will wash into our rivers, lakes, and even to the sea. Then that causes a lot of environmental damage. In protect cropping, growers tend to overfeed the crops. Sometimes they add double amount of the fertilizer the crop needs, and that causes issues, and the plants grow very vegetative, but does not have enough fruits. So we're trying to reduce the fertilizer use through this project. So we will work on cucumbers and eggplants. So as you can see here, we already have the cucumber plants grown in this greenhouse, and this is for the project. So we will engage a couple of students, 2 PhD students, and some research assistants. And this project is also in collaboration with Qatar University. The university is our international partner. They fund through this project to actually get collaboration and get some guidance from the successful stories through the CRC or through this greenhouse, and that can be used, applied in Qatar greenhouses. From Qatar University, that project is funded through the Qatar National Research Foundation. So we're looking into resource sustainability to solve fertilizer overuse, both in greenhouse and also in the field. This will help to improve productivity for Qatar farmers and growers, and eventually will help to protect our environment to reduce the damage of over-fertilization. Through our Master of Science program, we've already engaged the 2 students, Claudio and Demi. Demi is an international student from Africa, and she will continue to do her second stage of her Master of Science project, and with the hope she will transit into the CRC project as PhD. So she has already done a lot of work, and that's the Qatar project side, and the rest of the work will focus on the CRC fertigation program. We also have another student, Sonali. She's from India. She will also work together with us. So essentially we have 3 students working with us at the moment, and we will also have a couple of research assistants who are looking after the crop and also collect data as well. My previous research, mostly through the Australian Research Council or through Hot Innovation, and the CRC is a very different but very exciting opportunity for me. Through this, we were able to understand the grower's need, that's the company or the partner's need, and design experiment research have a better applied future. So, for example, my previous project with ARC, we look at the drought stress on crops, but looking at really the molecular level down to the details. Of course, we can publish papers, but application is usually at least 10 or even 20 years down the line. But with the hope involved in the CRC, we actually see very good potential for a potential application 5 years down the line for the research outputs. Some of those the research outcomes can potentially be translated. For example, the smart glass project, we've done a lot of the theoretical analysis, but now we are re-engineering this the film, and also we have the new lead film. they are showing very promising results and for potential application by growers in Australia and overseas. Our experiment results actually feed back to the company and to the leafy startup company, and provide scientific evidence on showing how good the leaf red film is. But there are also some other aspects that the film can be improved, or different colors can actually influence the plant productivity and also the quality. A good example is from the lettuce crop. We've already seen some varieties of lettuce can increase between 10 to 20% of the yield, which is very promising. The smart glass project was initially supported by Hot Innovation. That's back to 2017. So we had the first version of the smart film, which was engineered by Soonbin University of Technology. We ran through 9 cycles of crops. The general outcome is we achieved very good between 10 to 25% of energy saving, because the blue film reduced the high energy short wavelengths light coming in, which can reduce the heat load. However, a range of those crops such as eggplants, capsicum, and cucumbers, they have reasonably large fruit. The reduced light also caused a reduction of yield to a certain extent, but this does not affect lettuce too much, which is a good sign. Next version of the smart glass is currently being developed through the CRC and the Hot Innovation joint project to look at a better film which can keep energy saving property while maintaining the yield and quality. That's the ultimate goal for the next phase of the Smart Glass project. Smart Film project now, through the CRC, we have actually expanded. We were focusing primarily on the blue film, and we also have the red leaf film and the purple film coming up. So we are trying a few different options to find out the optimum film color to different crops. We will test them and make them applicable to the greenhouse growers, both low-tech, mid, and high-tech. Industry engagement is a huge part of this facility. So we built this greenhouse in 2017, and with the support of a range of companies. You probably can see companies over there: Fresh, Costa Group, Flavorites, Fresh Leaf, Greenworks, Protected Cropping in Australia. So the industry will benefit from this facility, both in research and education. So from research side, I just talked about the Smart Glass project. We also have the pollination project. Pollination has become an increasingly big issue, especially in protected cropping in closed greenhouse. Another key component of this facility is the education and training. So in this facility, with 400 square meter room, we run classes ranging from undergraduate subjects to postgraduate subjects. Those are very relevant to the industry. We have about a third of our students actually from the industry. They come in to a graduate certificate in protect cropping, graduate diploma in protect cropping, and some of them move up to Master of Science greenhouse horticulture. But for other students from the industry, they only come in, pick up a couple of subjects that interested to them, and they get what they can and upskill themselves through the course.